Hi, so this is the video lecture on measures of spread. So we've talked about distribution. What are the shapes of distributions? And then there are two things we'd like to know about a distribution. One is what is the center, and we've just looked at that. And the other one is how much variability is there in the data? So is the data all clumped up around the middle? Or is it spread out all over the place? And so that's what we're looking at in this lesson. We'll look at two different measures of spread. There's the range, and then there's the standard deviation. And now is a good time to also look at outliers. Those are the observations in a data set that are really far away from the others, that are not the usual ones. So to start with, let's look at the range. The range is really easy to calculate. It's just the maximum data point minus the minimum data point. So for example, in this data set, the largest data point is 100, the smallest data point is 20. So when you do the subtraction, you get 80. It's correct to say that the data ranges from 20 to 100. But when they ask you for the range, they're really talking about doing the maximum minus the minimum. Here's another example where you've got the largest data point, the largest is 73, the smallest is 67. Subtract them, you get 6. So this one has a smaller range than this one. Therefore, example 1's data is more spread out than example 2 data. The disadvantage to this formula is that it's really susceptible to outliers. If you have an extreme observation, you're not going to be able to really tell the difference, without actually looking at the data, whether it's just due to one crazy outlier or if that's actually typical in the data. That's my assistant, Stella, aka my cat, making noise over there. Okay, so the next measure is the standard deviation. That's the most widely used measure of spread. If you pick apart that term, standard deviation, standard means typical or usual. I'm trying to avoid the use of the word normal because that's an important word for us. And deviation means distance. So we're looking at the typical distance of observations in the data set away from the middle. So if you think about the standard deviation as the average distance, it's how far away the average observation is from the mean, you'll be thinking about it in the right way. That's not technically true because the formula doesn't quite work that way, but if you think about it that way, you'll have the right idea. So we have a sample mean and a population mean. And here we have a sample standard deviation and a population standard deviation. The sample standard deviation is a lowercase s. Sometimes it's used a capital S, but it doesn't matter. So s is the sample standard deviation, and then this Greek letter lowercase sigma is the population standard deviation. Your textbook uses SD, and you'll see this in journal articles sometimes, as a symbol for the standard deviation. Usually when they use SD in your book, they mean the population standard deviation. And in your book, when they ask you to calculate the standard deviation, they mean the population standard deviation. I realize this is a little bit confusing, and I kind of wish your book didn't focus on the population standard deviation, but we'll work around it. and I'll try to just be very clear about which one of these formulas I'm asking you to do. Basically, for any of the hand calculations, I'm going to ask you to do the population standard deviation because it's a little bit easier to understand conceptually. And that goes for MyStatLab as well. So in MyStatLab or in the book, do sigma. So we're using S to estimate sigma, and S is the statistic, sigma is the parameter. So here's the formula. I realize this might look a little intimidating, but we're going to break it down. So X represents the observations in the data set. And then if you recall, capital M is the mean of the data. So we're going to take every observation, subtract the mean, square the results, take the sum, divide by however many observations they have, and then take the square root. Let's do an example. We'll do a couple of examples. So if this is our data set, the one we looked at a minute ago, it's got a mean of 70. So here's what's inside the numerator of the fraction. We've got every observation minus the mean and square the result. So the mean was 70, so we take 67 minus 70 and square the result. So 67 minus 70 is -3. We square that and we get 9. 68 minus the mean is 70, so 68 minus 70 is -2. -2 squared gives you 4. Okay, so you can follow this through, but basically for all of these, you're just subtracting the mean and then taking the square. So that's what this step is. This means take the sum. So we'll take the sum and we get 26. So the next step is to divide by the number of observations that there are. In our data set, there were 5 observations. So we're going to take the 26, divide it by 5, and then take the square root. When we do that, we get 2.2804. So that's the standard deviation. That's sigma. We'll do another example in a minute, but let me point out that this quantity here that was in the numerator, this sum of x minus the mean squared, that's called the sum of the squared deviations. So that's SS. That's a notation that your book uses here and then later on in the course. So I want you to be familiar with that. Another piece of notation you need to be aware of is, another term, is the variance. So the variance is just sigma, or S, squared. So it's the number that's underneath the square root. So it's before you take the square root. That's the variance. The variance is important for statisticians because it has properties related to the normal distribution. But it's really not all that useful for us. We like the standard deviation because it's in the same units as the data. If we talk about what is the typical squared distance, we're talking about, if your data is in miles, we're talking about miles squared. If your data is in inches, we're talking about inches squared. So anyway, for this example that we just did, the standard deviation was the square root of 6.5. So the variance is 6.5. Okay, so that formula that we just did is for the population standard deviation. It's called the unadjusted standard deviation. And as I said, it's the formula that you're going to use when you do hand calculations in the textbook and in MyStatLab. To calculate the standard deviation for the sample requires an adjustment. That's why they call it the adjusted standard deviation. That formula, if you're calculating it for a sample, tends to underestimate the amount of variability in the data set. So there's a small change we use. Instead of dividing by n down here in the denominator, we divide by n minus 1. So instead of dividing 26 by 5, we just divide by 5 minus 1, which is 4. And when we do that, we get a different standard deviation. Okay, so this is the sample standard deviation, which is also called the adjusted standard deviation. And again, I wish your book didn't make a big deal out of the population standard deviation, but it does, and I want to stick with that, especially in the online class where you'll be relying maybe a little more heavily on your book. So in the textbook, there's a shortcut formula for the standard deviation. I really don't want you to use it. You're welcome to learn it if you want to, but I don't think the shortcut formula really saves you much work. And besides, I think doing the formula the way we've talked about it helps make sense of what the standard deviation really is, where it's basically the mean distance of the observations away from the middle. All right, so I'm going to insist that you use the what they call the definitional formula and not the shortcut formula. Let's go over to StatCrunch and look at how to do the calculation there. So I've typed in the data already, and we're going to go to the same place where we got the measures of center. So under Stat, Summary Stats, we've got columns here. So select our variable, and let's suppose we want the variance. We want the standard deviation, so I'm going to hit Control and click on what I want here, the standard deviation. This standard deviation is the sample standard deviation. By the way, this standard error is something different, so don't worry about it. We want the range, so we're going to Control and then highlight it. And if they ask you for the unadjusted standard deviation or the unadjusted variance, that's where those are as well. Okay, so the unadjusted, remember, is the population. So we'll hit Compute, and that's what our values are. Okay, so that's what those are the values we got when we did the calculation. So just to